Alright, we're going to take a look at the exponential function e to the x, and we're going to look at some derivatives of it. So first we'll start with y equals e to the x, and we know that the natural log is the inverse of e to the x, and we're looking to take the derivative. Since ln of x is a nice function, we're going to take the ln of both sides. And ln of e to the x is going to undo the e to the x. We're just left with x. So when I take the derivative of ln of y, that's going to be equal to the derivative of x. Okay, and so derivative of ln y is 1 over y prime. Derivative of x is 1. Y prime is equal to y, which is e to the x. So the derivative of e to the x is e to the x, so that's a nice, easy derivative to take of. And if we take the derivative of some e to the... we'll just write it again. If we take the derivative of an e to the u, where we have some differentiable function u in terms of x, by the chain rule, the derivative of e to the u is e to the u times u prime. So we're just going to do a couple examples of that. So y equals e to the, I think it's a 17x, so negative 17x. So derivative will be e to the negative 17x times the derivative of negative 17x, which is just negative 17. So the derivative there is negative 17 e to the negative 17x. Okay, let's try another one. Y equals 11 e to the 3x squared plus 7. So the derivative, it'll be 11 e to the 3x squared plus 7 times the derivative of the exponent, which is just 6x. So y prime is 66x e to the 3x squared plus 7. Alright, let's do another one. Y equals e to the 5x times the tan of 5x. So we're going to have product and quotient rule going on. So derivative of e to the 5x is e to the 5x times 5, and times the second function of tan of 5x, plus the first function, which is e to the 5x, times the derivative of tan is secant squared of 5x, and then chain rule times 5. We can factor out a 5 and an e to the 5x. What's left is tan of 5x plus secant squared of 5x. Okay, so not too bad at all. Alright, let's look at a couple more examples. Let's say y equals ln 1 minus e to the x divided by 1 plus e to the x, and we're going to use our quotient rule for not derivatives, but for logarithms, which is if I have a logarithmic quotient, we can break it up as ln of the numerator minus ln of the denominator. So this kind of becomes ln of 1 minus e to the x minus ln of 1 plus e to the x. Okay, so when we take the derivative of ln, it's 1 over whatever the argument was, which is 1 minus e to the x, times the derivative of the argument, which is negative e to the x. So derivative of e to the x is e to the x, minus 1 over the argument, 1 plus e to the x, times the derivative of the argument. Derivative of 1 plus e to the x is just e to the x. And the rest is just algebra. So we have minus e to the x divided by 1 minus e to the x. And I noticed that I have a conjugate, so I'm going to get a common denominator here. So we're going to multiply each denominator by its conjugate so we can get common denominator. And then we're just going to simplify that from there. Okay, so distributing, we have negative e to the x minus e to the 2x, and then distributing again, minus e to the x plus e to the 2x, and the bottom is the difference of squares. So we have like terms of, I don't know if you can hear him, but the cat just stepped on this and paused it, so he's a big helper. Um, Anyways, so we have common terms of minus e to the x. We have two of them. So minus 2e to the x, and then divided by 1 minus e to the 2x. Okay, and that's it. Let's do one more. We're going to use the second fundamental theorem of calculus to find the derivative of the integral from 0 to e x squared, ln of 1 plus t dt. So remember, when we're using the second fundamental theorem of calculus, essentially we're replacing the t with the x. But if it's not an integral from a constant to x, then we have to use the chain rule. So when I take the derivative, not x, what is this craziness? Put the x back in there. Alright, derivative with respect to x, so it's going to be ln 1 plus e to the x squared, and then times the derivative of e to the x squared, which would be e to the x squared, and then chain rule times 2x. And then we'll just rewrite that, 2x e to the x squared, ln of 1 plus e to the x squared. Looks like I forgot my square. Let's go ahead and put that right in. Okay, so that's taking derivatives of functions involving e to the x, or compositions with e to the x.